So today we're looking at question 6, and here is the question. You should be able to see this on the screen yourselves. And it says, find the coordinates of the stationary points and determine their nature. So stationary points are where the gradient equals 0. So therefore I need to do dy dx on this. So dy dx, and you need to take your time, don't rush, where that equals 0. And you can see here, hopefully you can see, you've got, rushing, there's an x there. You can see you've got an x in each term and a factor of 12. So you can divide everything by 12x out. So let's just have that. So it's 12x bracket x squared minus 2x plus x equals 0. So here one solution is going to be that x equals 0. So here's x equals 0. And if x equals 0, we can find, we put 0 into here, 0, 0, 0, 0, 1. So we know that it's at 0, 0, 1 is a stationary point. So I know that I've got stationary points at 0, 1. So that's one stationary point. The stationary point here, if or the other two, it's quadratic, might be 2. So let's do that, x, x. I've got, oh, that's a plus 1, see, rushing, slow down. So a product of 1 was 1 and 1, minus and minus, so there we go. So I know that when x is 0 or when x is 1, when x is 1, put it into here, you get 3 minus 8 plus 6 plus 1 is going to be 2, I believe. No, yeah, it's 2, isn't it? So y equals 2. So there we go. Now I need to determine the nature of these two. So to do that, I can double differentiate again. So d squared y over dx squared, and that drops down to 36x squared minus 48x plus 12. And I put these x values in here. If they're greater than 0, it means it's a minimum. If it's less than 0, it's a maximum. And if it's 0, you can't exactly say, but it's most likely to be a point of inflection. So we just have to see what happens there. Because we know that these are the points, the stationary points, we just need to know the nature of them. So let's put in the value of 0 into here. So if I put 0 in here, I get plus 12. So at that point, I get as plus 12. So that is greater than 0. So that's a minimum. That point is a minimum. Now let's put 1 into here. So I put 1, I get 36 minus 48 plus 12, I get 0. I get 0. So it's bound to be, well, it's not the maximum minimum, it's like to be a point of inflection. And what I want to do is, I want to know, is it positive to positive, negative to negative? Okay, so I know it's a point of inflection. And for the argument's sake, that's what you need to write at this stage here, is that it's an inflection. But the question does ask in part 2 to sketch the curve. So we're going to sketch it. So to do that, I'm going to wipe off a lot of what I've got here. We know that it has a minimum point at 0, 1. So we know it has a minimum point there. And we know that 1, 2, it is flat, stationary, but it's a point of inflection. So go like that. We also know that when x is a very, very small number, like minus a million, because it is the high power 4, that makes that negative or positive, etc., etc. So from using all that sort of logic, you'll be able to see that actually it starts on the top here and ends at the top there. You can see it crosses at 1 here, so it's not going to have any roots down here. So it's going to look something like this. Okay, and that's how you sketch it. Now, the second part to this, or the third part, is find the values for which the curve is concave upwards. Now, remember what concave upwards means. We have two shapes. So we have this shape, which is concave downwards, or convex upwards. Dyslexic nightmare. But this is concave, there's a cave and it's facing downwards, or concave upwards, it's facing up. And we know that with concave upwards, the second differential is greater than 0. So we know the second differential is greater than 0. And we can see, from here to here, there's a little concave upwards, here, it's going positive, and here. So that's where we know the values of the values for x, for which the curve is concave upwards. So it's here, and it's here. Okay? So we're going to determine these values. Now, some of you would have already kept your notes on the second differential, but I've had to wipe them clean here. So let's just go through without making any silly errors. And it's where the second differential is going to be greater than 0. So it's where the second differential is greater than 0. So I've done the first differential. Now let's do the second one. So 36x squared minus 48x plus 12. And because it's greater than 0, I can divide everything by 12. And I end up with 3x squared minus 4x plus 1. And I want that greater than 0. So factorize this. That plus 1, a bit strong contender, minus 1, minus 3, yes. Now how I look at this is a quadratic, a happy quadratic. So I could sketch it like that and say that it goes through a third and 1, and it will look like that. So it's greater than 0 here and here, but you can see here as well. So it is concave upwards when the values of x are less than a third, or where x is greater than 1 there, and you can see how that works.